Hello everyone, welcome back to College Algebra. Today we're in section 1.6 and this is other types of equations. And so in this section we're just going to learn how to solve several different types of equations. You know, we've already looked at how to solve linear equations and we spent an entire section talking about different ways to solve quadratic equations. Well, this section contains all the other types of equations that we need to be familiar with, but they don't really deserve their own section in the book. So here we will learn how to solve rational equations, equations with radicals, equations with rational exponents, and equations that are quadratic in form. So we've got a big job ahead of us. Let's get started. First, let's look at rational equations. Now remember, the word rational just means that the thing can be written in the form of a ratio or a fraction. So a rational equation is an equation that has variables in the denominator. Now, any value that would cause the denominator to equal 0 is called a restriction. A value that causes the denominator to equal 0 is called a restriction. And it's called a restriction because any number that causes a denominator to equal 0 is going to make that term where it occurs undefined. Remember, division by 0 is not defined. So a restriction cannot be part of the solution to an equation because it does not make the equation true and it won't check properly. So here is a practice problem for us. And notice that the instructions say decide what values of the variable cannot possibly be solutions for each equation. Do not solve. They're not asking us to find out what x is. They're asking us to find out what x cannot be. And we know that we cannot allow x to be anything that would cause a denominator to equal 0. It doesn't matter what's in the top. You might have variables in the top. That's fine. If the denominator equals 0, that's a problem. So we can't let 2x plus 3 equal 0, and we can't let x minus 6 equal 0. So first let's take 2x plus 3. 2x plus 3 cannot be allowed to equal 0. So I'm going to solve this just like I would if it were an equation, but the line through the equal mark means that we're actually finding out what x cannot be. So 2x plus 3 cannot be allowed to equal 0. And that means that 2x cannot equal negative 3. And now I'll divide both sides by 2. That means that x cannot be negative 3 over 2. Let's do the same thing for this denominator. X minus 6 cannot equal 0. That means that x cannot equal 6. And so the two numbers that x cannot be for this equation are negative 3/2 and 6. Those two numbers cannot be solutions. Now let's look at part B. So here we see that 4x cannot equal 0 and x cannot equal 0. So let's take the 4x. If 4x cannot equal 0 and we divide both sides by 4, that means x cannot equal 0. And of course, this denominator also tells us that x cannot equal 0. And so for this equation, the only number that cannot be a solution is 0. Now let's look at part C. This equation is a little different from the two that came before because this one has a trinomial in the denominator. And we cannot let x be anything that would cause any of these denominators to equal 0, so we'll have to factor this and see what would cause this denominator to equal 0. So if I look at this trinomial, I'll try to factor it into two binomials. X squared is going to be x times x, and then the signs are going to have to be different. And then the middle term has to add up to negative 1x. Last times last has to be negative 2. So I'm going to put a 2 here and a 1 here. And you'll see when you do outer plus inner that we get the middle term that we need there. Now notice that even though I have three denominators, I really only have two factors to deal with. X minus 2 cannot equal 0, and that means that x cannot equal 2. But also x plus 1 cannot equal 0, and that means x cannot be negative 1. These two factors are just repeats of these two factors, and so the only two restrictions we have are 2 and negative 1. So those two numbers cannot be solutions. Now, here are the basic steps that you're going to use when you're solving rational equations, and they are very similar to the steps that we saw in section 1.1 when we were solving linear equations with fractions. Remember how I taught you to clear the denominators? The reason I wanted you to learn how to clear denominators back there is because now we're going to use that same process to clear denominators on our rational equations. So when you need to solve a rational equation, the first thing you're going to do is find the least common denominator, the LCD, and I'll give you more information about that in just a minute. After you've done that, your next step is to clear the denominators. So the next thing you're going to do is multiply each term by the LCD so that the denominators cancel out. And then you'll be able to solve the resulting equation. The equation you get might be a linear equation or it might be quadratic. So whichever techniques you need to use to get to the final solution, that depends on the problem. But you'll just solve whatever's left at that point. And you'll have to remind yourself all the time that any number that causes the denominator to equal 0 is not a valid solution, and we will just throw those solutions out. Now, here is the process for finding the LCD. The first thing you'll need to do is make sure that all the denominators are in their factored form. You won't really be able to do anything helpful until all the denominators are fully factored. Then you're going to kind of make a list. You're going to put down all the factors from the first denominator, and then as you look at the other denominators, put down any factors from the other denominators that you don't already have accounted for. And when you look at the LCD, you should be able to see all the factors necessary to build each individual denominator, though not all at the same time. But I'll show you what I mean by that as we go along. So here is our first example. We have 3x minus 1 over 3 minus 2x over x minus 1 equals x, and we want to solve this equation. So notice that neither one of these denominators needs to be factored, so we can start by building our LCD. So I'm going to say that the LCD needs to contain a factor of 3 because that's the only factor in the first denominator, and it also needs to contain a factor of x minus 1. And then this last term does not have a denominator, so that's okay. So here is our common denominator. And remember I said that you should be able to look at the common denominator and see all the parts necessary to get back to each individual denominator. Well, when I look at the LCD, I see a 3, and that's all I need to make the first denominator. And I also see an x minus 1, and that's all I need to make the second denominator. So this is the smallest common denominator. So now what we're going to do is multiply each term by that least common denominator. And you'll notice that I've kind of spread the terms out here, and that's to give us room to multiply. So this is the first term. I'll need to multiply this by 3 times x minus 1. And notice that when I did that, I had to put this numerator in parentheses, because if you didn't have parentheses here, it wouldn't look like you're multiplying all of it by the LCD. It would look like you're just multiplying the last part of it by the LCD. So put your existing numerator in parentheses before you put down the new LCD that you're multiplying by. Same thing here. So I'm going to multiply 2x times 3 times x minus 1. And same thing over here. I'm going to multiply this side by 3 times x minus 1. So remember that the rule we're using here is that we can multiply an equation by anything we want as long as we do it to both sides. So I had to multiply everything on the left by the LCD, and I had to multiply everything on the right by the LCD. And now let's see what happens. When you look at the first term, you can see that the 3's are going to cancel out. Then when you look at the second term, you can see that the x minus 1's will cancel out. And then when you get to the right side, there's no denominator, so nothing is going to cancel out. So let's see where that leaves us. Back over here on the left, now we have 3x minus 1 times x minus 1 minus 2x times 3 equals x times 3 times x minus 1. Now I've written that as 3x times x minus 1. And so now here we have our equation all cleared of denominators. And so to solve this, we'll need to use the FOIL method to multiply these two binomials together, and we'll go ahead and distribute here as well. So right here at the beginning, using the FOIL method, 3x times x is going to be 3x squared. Outer times outer is going to be minus 3x. Inner times inner is going to be minus 1x. And last times last is going to be plus 1. Now on this next term, all we have is minus 2x times 3, so we can write that as minus 6x. And on the right side, we're distributing the 3x. So 3x times x is 3x squared, and 3x times minus 1 is minus 3x. And we're a little bit closer. So now, this looks like a quadratic equation, but you can see that the first thing you would try to do is subtract 3x squared from both sides, and that's going to cause your x squared terms to just drop out completely. Now let's add 3x to both sides, and you can see that if you do that, it will disappear from this side, and it will also make it disappear right here. So after we've added 3x to both sides, all we will have left is negative x plus 1 minus 6x. Now if we combine like terms here, negative x minus 6x is going to be minus 7x, and then we have our plus 1, and then on the right side there's nothing, so I'll put a 0 there. Okay, at this point, this is a linear equation, and so to solve it, what I need to do is just isolate the x term. So I'm going to subtract 1 from both sides, and that's going to give me negative 7x equals negative 1. And then I'm going to divide both sides by negative 7. And so that gives me x equals negative 1 divided by negative 7, which simplifies to positive 1 over 7. Now remember, we always have to look back at the original equation and determine if our solution was a restriction. In this case, you can see that the only x value that could cause a denominator to equal 0 would be if x were 1. So 1 is our only restriction. This denominator doesn't give us a restriction, by the way, because there's no variable here. So 1 would be a restriction, but 1/7 is not a restriction, so this is fine. Now, if you wanted to check your solution, you certainly could plug 1/7 back in here and go through the simplifying steps to verify that the two sides match. That would be an option, but it's not going to be something that's required as part of the solving process. So let's just move on to the next example. Here in part B of example 1, we have x over x minus 2 equals 2 over x minus 2 plus 2. So you can see that both denominators are fully factored. There's no factoring that we need to do. And you can see that both denominators are the same. So that makes it really easy for us to find the common denominator. It just needs to be x minus 2. So what we'll do is go ahead and copy down our equation, and I've spread out the terms so that I have room to multiply everything by x minus 2. So I'm going to be multiplying this numerator times x minus 2 and this first numerator on the right side and this constant term. Multiply each by x minus 2. And now you can see that on the first term the x minus 2's will cancel. On the second term the x minus 2's will cancel. And on the last term there's no denominator, so it doesn't cancel. That leaves us with x equals 2 plus 2 times x minus 2, which I've gone ahead and distributed here. So 2 times x gives us 2x, and 2 times minus 2 gives us minus 4. Now let's combine like terms on the right side and see where we are. 2 minus 4 is negative 2, so this is going to give us x equals 2x minus 2. And now what I want to do is combine my x terms. So I'm going to subtract 2x from both sides. If I bring the 2x over to the left, then that's going to give me x minus 2x equals negative 2. Combine like terms on the left, and I have negative x equals negative 2. And now divide both sides by negative 1, and we can see that x equals 2. But before you decide that 2 is the answer, you need to look back at the original equation and determine whether 2 is a restriction. And you can see here that yes, 2 is a restriction, because if you tried to check with the 2, then both denominators here would become 0 and the solution wouldn't truly check. So we're going to need to say that 2 is a restriction, and therefore it's not allowed to be a solution, and therefore we don't have a solution for this equation. So the solution here is empty set, or in other words, there is no solution. Now let's look at example 2 together, and it says solve each equation. And so here we have 3x plus 2 over x minus 2 plus 1 over x equals negative 2 over x squared minus 2x. This is a rational equation just like the last couple that we looked at together, but the difference here is that this equation is a little more complicated than the ones we had before. Notice that the denominator on the right side needs to be factored because this denominator contains a GCF. So let's go ahead and do that. I'm going to leave this first term and this second term alone, and I'm just going to factor the denominator on the right side. So to factor this, we just notice that it has a GCF of x. So I'll factor out the x, and then in parentheses, that's going to leave x minus 2. Now it's time for us to put the least common denominator together. So we'll do that from here. So remember, we start by putting down all the factors from the first denominator, so we'll need to put down an x minus 2. And then we put down any other factors that we don't already have accounted for. And so we'll put down an x. And then when we look at this last term, we already have an x, so we don't need to put this down again. And we already have an x minus 2, so we don't need to put that down again. So this is going to be our LCD. So let's just multiply each term by that LCD. And again, remember, I have put this binomial in parentheses to show that the whole thing gets multiplied by the LCD. So just like before, at this point we can go ahead and let the common denominators cancel out the denominator in each term. So in the first term, the x minus 2's are going to cancel out. In the second term, the x's are going to cancel out. And over here on the right side, both the x and the x minus 2 will cancel out. That's going to leave us with 3x plus 2 times x. Now I'm going to go ahead and distribute the x into here. So I'm going to write 3x squared plus 2x. Right here, everything has canceled except the 1 times x minus 2. So we'll go ahead and distribute that 1, and that's going to give us plus x minus 2. And then over on the right side, everything has canceled except the negative 2. So I'll put equals negative 2. Now you can see that this is going to be a quadratic equation. And so we would hope to solve this by factoring. And to do that, we're going to want 0 on the right side. So let's start by adding 2 to both sides. You can see that if we add 2 to both sides, we'll get 0 here, but we'll also get rid of the constant here. So I'm just going to mark those out. And that's going to leave us with 3x squared plus 2x plus x equals 0. Now when I write this down, I'm going to go ahead and combine the two like terms we have here. So it's going to be 3x squared plus 3x equals 0. Now because this is quadratic, the best thing to do first is to try to solve it by factoring. And sure enough, I see that I have a GCF of 3x here. These two terms share a common factor of 3x. So if we factor that out, then in parentheses, we'll have x plus 1. And that equals 0. Now, I just want to make sure everybody understands this factoring is correct because if you distribute the 3x back in there, it goes back to this form. And so 3x times x plus 1 equals 0. And if this times this equals 0, it means one of these has to be 0. So if 3x equals 0, and we divide both sides by 3, that means x equals 0. And if x plus 1 equals 0, and we subtract 1 from both sides, that means x equals negative 1. So our two potential solutions are 0 and negative 1, but we need to make sure that neither one of them is a restriction. If you look back here where we factored this denominator, you can see that an x value of 2 would cause this denominator to equal 0, and an x value of 0 would cause this denominator to equal 0, and either one of those would cause this denominator to equal 0, either 0 or 2. So this 0 is not qualified to be a solution. This 0 is a restriction and it has to be thrown out. So our only remaining solution is x equals negative 1. Now we're going to solve the part B equation together, and you can see again that one of the denominators needs to be factored before we can build our common denominator. So I'm going to go ahead and copy down the entire equation, and I've left everything the same except I have spread it out, except on this denominator on the right side, I see that this needs to be factored. Now this is a difference of squares, so remember a difference of squares factors into a sum and a difference of the same two terms. So since this is x squared minus 1, the square is 1, and so this is going to factor into x minus 1 times x plus 1. And now we're ready to build our common denominator. So for the common denominator, we put down all the factors from the first term, which there's only one factor here, and that's x minus 1. And we put down any additional factors that we don't already have. So I'll need to put down an x plus 1. Now when I look at this denominator, I already have an x minus 1 in my LCD, and I already have an x plus 1, so I don't need any additional factors, and x minus 1 times x plus 1 becomes our common denominator. Just like we did before, we'll multiply each term by that common denominator and see what will cancel out. On the first term, the x minus 1's will cancel out. On the second term, the x plus 1's will cancel out. And on the right side, both the x minus 1 and the x plus 1 will cancel out. And so that's going to leave us with negative 4x times x plus 1 plus 4 times x minus 1 equals negative 8. And to finish up here, let's go ahead and just distribute. So we're going to have minus 4x squared minus 4x plus 4x minus 4 equals negative 8. Now you can see that we have an x squared term here, so we know this is a quadratic equation, and we're probably going to want to try to solve this by factoring, which means we're going to want a 0 over here on the right side. But before we get that 0, I noticed that these two terms here would add up to 0. So negative 4x plus 4x is going to make our x terms go away. And let's just go ahead and do that. So we're going to have negative 4x squared minus 4 equals negative 8. Now since this is quadratic, we know we want a 0 here, so let's go ahead and add 8 to both sides. That would give us negative 4x squared plus 4 equals 0. Now whenever we're factoring, it's always more convenient for us if the x squared term is positive. And so I would like to get rid of this negative. And one way we can do that is to multiply both sides of the equation by negative 1. So if we distribute the negative 1 here, that's going to give us 4x squared minus 4. And of course on the right side, 0 times negative 1 is still 0. Now this is a little easier to work with because the x squared term is positive, and now you can see we have a GCF of 4. So let's factor that out and see what's left. If we factor out of 4, then in parentheses we'll have x squared minus 1. And of course that is a difference of squares. We saw this in the previous example. So if we factor this difference of squares, it will become x minus 1 times x plus 1. So on the next line we're going to have 4 times x minus 1 times x plus 1 equals 0. Now according to the zero factor property, if this times this times this equals 0, one of them has to be 0. It can't be the 4 because the 4 doesn't contain a variable, it's just a 4. So either x minus 1 equals 0 or x plus 1 equals 0. If x minus 1 equals 0, then x equals 1. And if x plus 1 equals 0, then x equals negative 1. But before we decide that these are our solutions, remember we need to see if either one of them is a restriction, because if they are restrictions, we have to throw them out. And sure enough, when we look back at the original equation, if x equals 1, then this fraction will be undefined because this denominator would be 0. And if x equals negative 1, then this fraction would be undefined because this denominator would be 0. And either one of those numbers would cause this denominator to be 0. So both of these solutions are problematic. They both have to be discarded. And that means that we don't have a solution for this equation. So we will just say there is no solution here, or the solution is the empty set.